Hi, welcome to the Calculus 3 assignment practice series. We are in the unit multiple integrals. So for this video, we're going to take a look at the homework assignment number A in this unit and regarding to the change of the variables in the multiple integrals. Like we talk about how to use the Jacobians and then how to define the region from one transformation to another here. Okay, so we're going to do a few problems and hopefully it can help you to get it started. Okay, now let's go to our worksheets here. Okay, so the first ones here, I'm going to show you just from the very beginning, some very mechanical ones. So the first, let's take a look, how do we do the Jacobians here, right? So from the Jacobians, I know the Jacobian is the way we define this is how do we define the Jacobian is rho of xy and then the rho u, rho v. So that means you take the partial derivative of x to the u, partial derivative of x to the y, and then you find the determinant for that. Okay, so let's take a look here. So Jacobians here. So the first is the partial derivative of x to u. So what is the first terms here you have? You will have a 2u plus what? Plus v's, right? And then you take the x to the v. So what is the partial derivative for the v? U is a constant, so u square cancel. So what is here is u, right? Okay, now the bottom here, you take the partial derivative of the y to the u first. So if you take the derivative for the u, what you have here is v squares, right? Now you take the partial derivative of the y to the v. So what you're going to have here, you have 2uv's, right? And then you do what here? You find the determinant. So you do a cross product. So what is the cross product here we have? So we have a 2u plus v times 2uv minus u times the v square. So if you simplify this a little bit, it will give you 4u square v and plus uv squares, right? So this is what is my Jacobian. So all the remaining 6 of these are very similar and very mechanical. You just take the derivative, partial derivative of x with respect to how many the variables you do in the transformation. Okay, now let's take a look the problem number 8. So this one's here is, remember when we do this, the one of the main goal is try to make your integration region is pretty simple, right? So let's say S is the square bounded by the line, da, 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 da. And now this is my transformations here, x equal to v, y equal to the u times 1 plus v. So let's take a look. What did we do to what before the transformation, what is our integration regions here? Okay, so let's take a look at these ones here. So first, this is my UVs, right? So let's say this is a square bounded line. So U equal to 0, U equal to 1, V equal to 0, V equal to 1, see here. Okay, so these areas here, this is my what? This is my S areas, right? So this is the S area. It's a nice squared area. So let's take a look, what is the original, the areas here. Okay, so in order to do that, so let's call these lines here, let's say this one's here, these boundaries here, let's say this is S1, okay? And this boundary here, let's say this is S2, and this boundary here, let's say this is S3, and this boundary here, this is S4 here. Okay, so now let's take a look at what is the area I'm going to, what was before the transformation, what is XY, the boundary area, okay? So now let's start first. So let's start with the boundary S1 here. So S1, I know is V is equal to 0, right? So X equal to the 0, V, so X equal to 0, Then what is the y? See here, y is equal to what? Y equal to v equal to 0, y equal to u, see here, right? Okay, so from here, so S1, the end point here, right? So I have two end points here, right? So this is the 0, 0, and this is 1, 0. So for the 0, 0s, right? So I have, so this is 0, 0. Then the 1, 0. So u is equal to what? U is equal to 1. So what is this one give me? Is 0 what? Is 0 ones here. Correct? Okay. So now let's take a look here. So this will be my, okay, so here. Let's do this. So this is xy. So the first S1, I'm transfer to 0, 0, and what? 0, 0, and the 0, 1 here, right? So this boundary, right? So it's the transformation for S1 here, okay? Now let's take a look the next boundaries here, S2 here. Okay, so S2 is here. S2 is here. So what's that mean? That means U is equal to what? U is equal to 1. Correct? If U is equal to 1, then plug back to here. So what is X here? X equal to V, and the Y equal to what? Y equal to 1 plus what? V squared. Hey, x equal to v. So what is here? I change this one here. So y is equal to what? 1 plus x squared. So I change it to a curve here, right? Okay, so now because this is u equal to 1, so this is S2s, right? So for the S2s here, so for this point, okay, so for this point, this is what? This is 1, 0, right? So this is a 1. So this is u equal to 1, v equal to 0s, right? So what is the point I have? I have 0 and what? 0 and 1s, right? Then for this point here, right? So for this point here, this one used to be what? This is 1, 1, correct? Okay, so this one is 1, 1. And now I'm going to transfer here. So what is this one going to transfer to? 1 and what? And 1 and 2 here, correct? So x is equal to 1 and y equal to 2 here. So this is 1, 2, 1, 2. Okay, so let's take a look. What is this second one going to transfer to? Okay, so the second one, so from the, right, so from the 0, 1, so it's from here, because then they have what? They have quadratic equations, right? So it's a shift up 1, and it's quadratic. So this is my, so when x equal to 1, so it's 2, so this is a quadratic, right? Okay, so what is this ones here? So this is I'm going to color it. So this curve is my S2 here. Okay, so this is my region S2. Okay, so now let's continue do S3 here. Okay, so S3 is here. So what is S3 here? What is S3 here mean? See, let me erase this. Okay, so the S3, that means V is equal to 1. Am I right? Okay, if V is equal to 1, you plug back to x equal to V, so x equal to 1. And y equal to what? Y equal to 1 plus 1 squared, so it's a 2u. Okay, all right, so the 2u's here. So with this 0.11, I'm still going, so with this 0.11, I'm going to give a point of what? So let me use the color coding, so make sure we don't mess up the point. So with 0.11, so I'm going to have a 0.12. Am I right? Okay, now for here, this one's here, this is the 0, 1's here, right? So this is 0, 1. That means u is equal to 0 and the v is equal to 1, u is equal to 0, and v equal to 1. So this point going to give you what? 1 and what here? 1 and so u is equal to, so v is equal to 1. So it's 1 plus 1, x equal to 1. So this point will give you 1, 1. See here, right? Okay. Okay, so no, 1 zeros, right? Because u is equal to 0, y equal to 0. Yeah, because u is equal to 0. Okay, so now this is my other point here. So it's 1, 2 is here, 1, 0 is here, right? So this is my third one here, right? So this is what is the S3 transfer true. Okay, so now let's take a look at the last one. It's S4. S4 is this line. So what is this line? This line is u equal to 0. Okay, if u equal to 0, okay, so then the x equal to what? X equal to v. Then u equal to 0. What happened to y is here? Y equal to 0. Then this one u equal to 0. Now what is this point here? This point is 0, zeros, right? So what is the point of corresponding to here? So it will be corresponding to the 0, 0. And then this one here is 0, 1, 0, 1. So we're corresponding to the 1 zeros, right? Okay, so 1, 0 is here, 0, 0 is here. How? We got it. So this is my S4. Okay, so this is the area. So this is the area for the xy. So if you integrate along the xy, this is the integration region. So you see here, after you do the transformations, right? So the UV region is a lot easier than try to do the integration over these regions here. Okay, now let's take a look at another one here. There's number 10 here. So the S is the disk, u squared plus v squared less than 1. Then here is my transformation, x equal to the AU, y equal to the BV. So let's take a look at what is the original XY regions here. Okay, so let's take a look here. So this is U and V here, right? So this is U and V. So my S regions here is U squared plus V squared equal to 1. So what type of the region is that? It's the circles, right? With the what? Radius is equal to what? -1. So it is a circle. So it's these circles here. Okay, so this was my original, no, not original, this is my S regions, right? So this is after transformation. This is what is my S region. Okay, now let's take a look. I did a transformation, x equal to AU, y equal to BV. And now let's take a look at what is the XY original. Okay, so x equal to AU, so I know U is equal to what? X over what? A. And what is V here? V is Y over B here, correct? Because I know U squared plus V squared equal to 1, so I say U squared plus V squared equal to 1. I need to find this boundary to see how do I transfer this boundary like we did before. Previously, we have 4 segments, right? So we need to do 4 segments. But in here, I only have the 1 curves here. So how do I do these curves here, right? So now I say U squared plus V squared is 1. That's a circle. Okay, so now I know this is what? This is x squared plus y squared, b squared is equal to 1. Oh, so what is this? What is this here? This is what? This is ellipse, right? So now I can do the xy, so what was original? Because this is ellipse, so I know the x here is a, and this is negative a. Depends on b or a or b is bigger, so we don't know, so we can just do like this, right? So it's ellipse here. So now I can just graph this ellipse here. Right? So this is what? So this is my original integration region. If you want to integrate over x and y here, as you can see, of course, it's a lot easier to integrate over the circle, right? Because I probably can use the polar transformation to simplify it. Okay, okay, so now let's take a look here, right? So now let's take a look at how do I do the next ones here. Okay, so this is the, the x equals, so original transformation. Let's see how do we simplify that and how do we carry out the integrations, right? Okay, so here this is x, this is x minus 3y dA. R is the triangle region from the 0 to 1 and 1, 2. Okay, oh boy. Okay, let's start to graph it. Okay, so this one's here. This is xy, right? So this is 1, 2. So this is 1, 2. This is 1, 2, 1, 2. So let's say I have this region at the vertex is 0, 0, 2, 1, and 1, 2. Whoa. I have these triangles here. Okay, so obviously, you try to integrate, you probably need to, if you don't want to do the transformation, you probably need to integrate by divide this region to a couple of regions and then integrate separately, okay? So let's see here, all right? So let's call this line is R1, this one is R2, and this one is R3, okay? So the R1, all right, so now I'm going to do the transformations, right? So R1, if you put it into the line, so what is R1? This is the 0, 0, 2, 1. So this is y equal to what? Half of x, right? So slope is 1/2. Okay, so R3, the slope is 2. So this is y equal to the 2x. Okay, so for R2's here, so this is 2, 1, this is 1, 2, right? So the R2, if you put it the 2 points formula to the line, what you have here, you will have this is x plus y equal to 3, okay? So those are the 3 lines associated with these triangles here. Okay, now let's take a look. We say, okay, now we do this, x equal to the 2u plus v, y equal to the u plus 2v. Let's see, how do we transfer this one into our integration regions here? Okay, so we do, because we do not like those type of problem, because then we need to do each one, so just need to be patient. So we say the R1 is a line y equal to what? 1/2 of x, right? Okay, so 1/2 of x. So y is equal to u plus 2v is equal to 1/2 what? 2u plus v, right? So it's kind of like a backward to what we did before. A while ago we did is we know the uv, we try to find our original integration region for xy. Right now we know the xy, we're going to find what is our simplified region for uv. Okay, so in here, so u plus 2v equal to the u plus v. So in here, you solve this, you will get v is equal to what? Okay, so you will get a v is equal to 0 here, right? So if v, okay, so the v is equal to 0s, right? So now this one's here, x equal to the 2u, y equal to the u's, right? Because v is equal to 0. So what is the first point I'm having here? Then u is equal to what? U is equal to u equal to 1s, right? So it's 1, 0, right? Because here, this one's here, you said y equal to u right now, x equal to 2u. So then for this point, 2, 1, right? So x equal to 2, so u is equal to 1, so it's 1, 0. Okay, so now let's take a look at this integration here. Let's graph it. Okay, so this is the uv, so this is 1, this is 1. Okay, so v is equal to 0, this is the u is 1, 0. So that's pretty cool, right? So I transfer my first one to here, right? So u equal to v equal to 0, u equal to 1. So this is my R1, I transfers here. Okay, now let's take a look at the R2 here. R2 original is x plus y equal to 3 is the line. Then we do the same way to plug in. So this is 2u plus v plus u plus 2v equal to 3. All right, so you simplify that. Oh, this one is simplified to pretty good. So it's 3u plus 3v equal to 3. So what is u plus v? U plus v is equal to 1. Oh, that's pretty good. U plus v equal to 1. So that means it's a line. So here have x-intercept 1, y-intercept 1. So this is my R2 transferred to that. So it's u plus v equal to 1. Superb. Okay, so now R3 is here. So R3 is y equal to the 2x's here, right? So you plug in the same thing. Y is u plus 2v is equal to 2x. It's 2 times 2u plus v. Okay, so then you simplify, you got to 3u equal to 0. So it's equal to u equal to 0. Okay, u equal to 0, and then the x equal to v, and the y equal to 2v's, right? Okay, so now I'm looking for this point, right? So this point here, so it's 1, 2. So y equal to 2, right? So this is y equal to 2. So what is the value of here? So we know from here, we know v is equal to what? V is equal to 1. Okay, so now we can plot. So 0, 0, and 1, right? 0, 0, 0. So this one, this one, this is my R3. So I know I transfer, right? So I transferred to what? I transferred this triangle to this triangle. This will make the integration a lot easier. Okay, now before that, we need to do a Jacobian also, right? Okay, so the Jacobians here, Jacobian is partial for x, right? X partial is 2. And x partial to v is 1. 1, y partial to u is 1. Y partial to v is what? Is 2. So your Jacobian is -3. But then when we take integration, okay, so now I can change my integration. X minus 3y. So let's say x minus 3y. What is x minus 3y? X is 2u plus v minus 3. So 3 times u plus 2v's, right? So what you can simplify that? So 2u minus 3u. So this one I can simplify to the negative u. V plus -6, so it's minus 5v. Okay, so now I have negative u minus 5v times the absolute value of Jacobian, so it's -3, absolute value is 3. Then you can do dv du. Okay, so now be careful because this one is not the rectangle, so I need to be careful when I do the integration. So dv, I'm going to do like this way, right? So according to the v directions here. So then here you can write it here. So you say this is negative u minus 5v. You can put a 3 in the front like Jacobian. So dv, so v is go this direction, is from 0 to what? 1 minus u. Then the dv's here, you just integrated the u here. I'm sorry, du's here is what? 0 to 1 here. Okay, so be careful, right? So this is a du, so this is a 0 to 1. And this is the dv here. So the dv, because they do bounded by these lines here. Okay. Right. Okay. So this is now you should be able to find this integration. There's nothing tricky about this integration. Just do the typical integration and you should be able to find it. Okay. Now let's take a look. One more problem. Then I think you should be very good at this. Okay. Now in here, this is the other ones here. We say, I want to integrate this x squared dA. R is the region bounded by the ellipse here, all right? And then I want to do this transformation, x equal to 2u, y equal to 3v. Then let's see how do we do integrations here. Okay, so first, this is x, this is y, correct? Okay, so this ellipse is 9x squared. Okay, so this ellipse is, let me see here, this is, okay, so this is a 9x squared plus 4y squared equal to 36. So let me change it to the typical standard form for the ellipse divided by 36. So this is an x squared over 4 plus y squared over what? 9 equal to 1, right? So I know the x region touch at 2, right? 1, 2, 1, 2. Then y is 1, 2, 3. 1, 2, 3, right? So this is 3, -3. So this is my ellipse here. It's upside down ellipse. Or some people not upside down. Some people say it's standing up ellipse. Okay, I really did a terrible job of drawing this ellipse, but I guess you guys see here, that is the ellipse. Okay, so this is a standing up ellipse here. Okay, so now I'm going to do the, integrations, right? Okay, so now let's take a look here. So the first here, right? So I'm going to do I need to change this one, 9x, this boundaries, right, to a boundaries here. Okay, so let's see here. So how do I change that? Because this is one line, so I need to change it. So it's 9x squared. So I said 9x squared, this boundary is 9x squared, right? So it's 2u squared plus 4y squared, 3v squared, and is equal to what? It's 36, right? Okay, so now this one is here, 36u squared plus 9 squared, 3 squared is 9, 9 times 4, 36. Oh, it's beautiful. So it's 36v squared equal to 36. Well, what I have here, u squared plus v squared equal to 1. So I know I transfer this ellipse to a what? To a circles, right? So I to a circles here. So this is my, okay. So this is my new region, right? So this is the region I'm going to integrating under, right? So we say that's good because now this is what is our S regions after transformations, right? So this is a circle. Circle is always easy because I always can use the polar transformation if needed, all right? Okay, so now let's take a look. And then before we set up the integration, what do we need here? We need the Jacobians, right? Okay, Jacobian is x take the partial for u, so it's 2. X take the partial for v. What is here? There's no v, so it's 0. Y take the partial for what? For u, so no u is 0. Y take the partial for v is what? It's 3. So what is the Jacobian cross product, right? So I do a cross product here. So what is the Jacobian here? Jacobian is 6. Okay, so now let's try to settle it, all right? Okay, so this one's here, okay. I'm going to do a double integrations, all right? So x squared, so what is x squared? It's 4u squared times Jacobian is 6, right? And then I do du dv. Under what region? Under this new region, u squared plus v squared equal to what? Less than equal to what? This is what? This is a perfect candidate for what? For the, for the polar transformations, right? So polar transformation, so I will say u is equal to r cosine theta, v is equal to r sine theta. Of course, the r here is what? Okay, so that will be the, the r's here will be ones, right? Okay, so the r's here will be ones here. So now the u is equal to the r cosine theta, v is equal to the r sine theta. Remember what is the Jacobian for these transformations here? The Jacobian is r, right? So don't forget that. Okay, so now let's finally change that. Okay, so 4u squares, right? So times 24. So this is 24 u square. U is what? It's r square cosine square theta. Correct? Don't forget to times the another Jacobians here. This is another Jacobian from here, right? So the Jacobian from the polar transformation. Okay, now you can do dr d theta. So what is the r's here? From 0 to 1. What is the theta's here? Is 0 to 2 pi here. Okay, so it's very, very simple. And because here they are separate, in fact, you can do this integration. You can say 2 pi, you can put a 24, okay? Then you can have a cosine square theta d theta, and times 0, 1, r to the third dr. You can separate it into like two different, the integration. So this one's here turns out the answer is very beautiful. It's 6 pi here. Okay. All right. So I guess that's it. And of course, the challenges here, all these problems here, they give you what is the transformations, right? So they give you, say, hey, x is equal to the 2u, y equal to the 3v's here. How about if they do not give you? So what will be the right transformation to use? That will take experiences, right? So also it depends on what is the integration region, the x and y integration region is, then maybe that can help you to define the appropriate transformations, okay? All right, I hope the few problems I did here can help you to get a good start for these sections. And okay, that's it. Nice to talk to you, and hope this helpful, and you'll be able to do the remaining problems here. Okay, bye.